Hello, welcome to Enlightning. I'm so glad you're here. Today we're going to learn about Argo Rollouts with Nicholas Morey. Welcome, Nick.
Hello.
Hi, tell us about yourself, please.
Hi, I'm Nicholas Morey. I'm a senior developer advocate at Acuity. I have a background as a Linux systems administrator and DevOps engineer, and then I eventually got convinced into talking about tech rather than having to be on calls. So here I am.
Is that why you're just to avoid being on call? That's why you're here with us today.
It's a surprisingly big part of it. Yeah.
Well, I'm so excited to learn everything you have to teach. Argo. So, to give you some context, Nicholas, we're doing a whole, I say we, I don't know who the we is. It's just me back here. This is a one woman show, big time. But I'm doing a series of enlightenings around observability because on
Mm.
the other show I host, You Choose, we're going to do a choose your own adventure around observability. So now it's for some, for like maybe even me a little bit, Argo rollouts feels like a little bit of a departure from observability generally.
Mhm.
But we're gonna learn more about it and how it all fits together. I'm so excited.
Fantastic.
So fantastic. So oh look, Kormaju's here. Hello. Thanks for coming, friends. I'm glad. Um, so let's just dig right in and talk
Sure.
about. I like to start the streams by talking about what was the world like before Argo rollouts existed? Why did Argo rollouts need to be created?
Yeah, let me kind of set the stage for us here for the before. So, let's say I have this application that I'm deploying into Kubernetes.
Okay.
Let's call it a stateless application. So I'm using the standard Kubernetes deployment resource. The before state is the deployment resource, and we'll kind of follow that along as we go through the rest of the examples. So if we take a look at a basic deployment resource in Kubernetes, it
Uh huh.
is a template with a number of replicas. And when you deploy that into a Kubernetes cluster, it generates a replica set and then a pod. And so this is like very basic Kubernetes knowledge. It's not particularly special to Argo rollouts, but that uh, that architecture
Uh
is
huh.
fundamental to the normal deployment process, the delivery of changes into Kubernetes. Because every time you make a change to that pod template, it's going to
Uh
generate
huh.
a new replica set, which then generates new pods. So your rollout process, a bit of foreshadowing going
Uh
forward,
huh.
your rollout process is to generate a new replica set that then scales out a new set of pods. So if I was to kind of start visualizing it, the key points are we have a deployment that creates a replica set that creates pods. Um, and that
Okay.
creates the foundation for a simple rollout in Kubernetes using the core resources.
Deployment creates replica set, creates pods, one or
Exactly.
many
Yeah.
pods. Yeah.
And then, so a change to the pod template within the deployment generates
Mm-hmm.
a new replica set. So you tend to have, during a rollout, two replica sets alongside each other that then start spinning up new pods. So you can almost draw a line from deployment to a new replica set to new pods, and that'll represent our rollout in the before state.
So, hello to Epic Tralala. Good to see you here again. Is the point that you're trying to drive home here, like even when you make a change to pods, it's going to change everything?
Yeah, it's the point I'm trying to make is that to be able to roll out a new change,
Uh huh.
you don't simply modify the existing replica set and then start rolling out new pods. The You get a new replica set, and then in order to update it, the standard deployment gives you two options. You can either do a rolling update from the old replica set to the new one, or you can do a recreate update from the old replica set to the new one. And so those are the only two deployment strategies that Kubernetes by default provides you. And so that's really important to understand here is that with the rolling update, the new replica set ends up uh, the new replica set ends up spinning up some new pods while tearing down old pods at the in the old replica set. So you're to some precision, uh, gradually rolling out from the old replica set to the new one. And the recreate strategy tears down all the old pods from the old replica set before deploying the pods from the new replica set. And those are really the only two functionalities that you get for rolling out a change into a Kubernetes cluster with a deployment.
Okay, I think I'm going to draw a picture here too.
Hmm.
But the idea is the same deployment will have more than one replica set in it if as with a Kubernetes rollout, not an Argo rollout.
Yeah, and it's really those two replica sets provides all the controls that is the only way you can provide controls for how you want to deploy a change, how you want to transition from old version to new version. In the standard Kubernetes resources, you rely on those old and new replica sets in order to do that. And then really your only controls are in what order and how quickly do you spin down old pods and create new pods.
Okay, so we have one deployment. We have the original replica set.
Yeah, the old version, if you will.
Yeah. Old replica set, or S. And then we have the older pods. Let's say we have 3 pods. Why not?
Yeah, that should be enough to illustrate the
Do
idea.
you know, let's do, instead of old and new, let's do V1 and V2. I like
Yeah.
that better.
And later we might even be able to say blue and green, but we'll get into that.
V1 pods. And I see we have more friends in chat. Pods. Okay. And then, so then when we make a new one, it makes a whole new replica set.
Yeah, assuming the changes to the pod template. Small nuance here that we probably don't need to draw out is that if you only change the number of replicas on the deployment, it's simply going to use the old replica set and change the number of pods. So it's any change to the template, the pod template, to the configuration of the pods generates a new replica set, which then initiates that rollout from old to new, from V1 to V2.
And then you said, just real quick, I'm going to say hi. Hello, Ganatech. It's good to see you here again. I appreciate you coming back. And hello, Nom de Plume, who's new here. Welcome. So you said there's 2 ways now that this can happen. It could either be a recreate strategy where all the pods go away and your application is not accessible, and then they all come back up as V2 pods.
Yeah, and that's an important point that you made, is that there's downtime with the recreate strategy because you are fully removing it and then recreating it.
Or there's the rolling update, which I imagine is more popular. I actually don't even know why you'd ever use recreate, honestly. Maybe you can shed light there.
Yeah, I can go on a small tangent about recreate. It's really ideal if your application can't handle having a new and an old version available at the same time. So if you're doing like you've got incompatible API versions and you need to fully remove the old API before introducing the new one, that's when recreate comes in. Or like if the old and new version are both sharing the same resource and they're going to fight over that resource, you need to fully remove, like tear it down and then spin it up. It's not ideal, and I think it's maybe a sign that there's a design decision wrong with your application if you're required to use recreate, but that's probably a whole other story.
So two strategies, update strategies that are native to Kubernetes. And then we have recreate.
And so rolling update is the default. It's what Kubernetes expects most people to use.
V1 goes down, then V2 goes up.
Yes.
Or rolling update, which is the default, which I didn't know. One V1 pod goes down. One V2 pod goes up.
It would actually, it would be the reverse, I believe. I believe it would.
Do an extra one.
Yeah, it brings up the new pod, and so I'll briefly talk about like that idea of bringing up old before tearing down new is really the only control that you have over the granularity of your new update, of exposing your new update to a subset of users. With rolling update, you can say, I want to bring up 25% new pods before tearing down 25% of the old pods.
So it's not even necessarily one to one. One goes down, one comes up.
Yeah, you could change it. You could change your max unavailable to be different from your max surge. So surge is how many extra you're willing to have, and unavailable is how many you're willing to live without. And I think the default is 25 and 25. So if you have 4 pods, you're willing to have 5 pods before bringing down the one old pod, and so on. But that's how limited you are with the standard Kubernetes deployment. Is it's based on number of pods and percentages of how many old versus how many new pods. You have no other control over exposing, this subset of traffic for this long to this set of users, or to say that I want to route traffic intelligently based on additional parameters, which we'll get into.
I love it. So should I write something down about max surge?
No, that's a tangent.
Okay.
Yeah.
So we got the basics here of how Kubernetes does it. And hello, Daniel. Glad you're here, friend. And now we're going to you kind of alluded to this, but I think I want it more concretely stated. Like, what are the shortcomings of doing it this way?
Yeah, to put it concisely, you have very little control over the speed of your rollout. You have no ability to precisely split traffic between the old and the new version, between V1 and V2. And then even without that, you have no built-in mechanisms for how to verify that the new version is healthy before continuing on with your progression. You can like maybe asterisks on that. You can take advantage of the readiness and liveness probes, and that can stall the rollout, but you have no automated rollbacks. You have no deeper analysis into like specific metrics that are coming out of your application. So
will you repeat those things
yeah,
a little more slowly?
certainly. Yeah.
Yeah.
So to start off with, you have no control over the speed of the rollout. Speed is a big one, because if you go too fast, you may end up with globally wide outages that prevent people from going on their flights, or from
just hypothetically speaking.
Hypothetically, yeah. You have no ability to precisely split traffic between versions. So traffic splitting is a big one, because you want to be able to say that I want this specific group of users. I want all of my users on Firefox to go to the new version because we test something that is broken in Firefox. So I want 5% of my Firefox users to go into this version, you have no control at that level. All your
Mhm.
control is at the pod number of pods level, so you have
Mhm.
no insight into the actual application traffic.
Uh-huh.
Um, and then so after speed and traffic splitting, you have no way to verify canary deployments, or let's just say
Mhm.
deployments at this point. You have
Okay.
no in-depth verification on is my application performing the way I expect it to be
Mhm.
able to progress on to a larger subset of users after you've done that verification, or
Okay.
we'll get into it.
Okay.
uh, and then finally the readiness probes can prevent it from progressing forward with the standard deployment, but you have no automated rollbacks with the standard deployment. It can't detect, oh, my probe is failing, I should maybe revert the version of my application because of that. Instead, it
These are
just
all
stalls the progression.
okay. We have a question. When recreating new infrastructure, will there be any impact on the existing environment?
Mm. I think we'll definitely be digging deep into that exact problem space of like, how do I recreate new infra without affecting the old
Uh-huh.
environment. So I think I'd like to answer that as we progress through what Argo Rollouts introduces, because that's the problem space that we're looking at.
I love it. And then Cormaggio has another one. What about the policies and secrets apply
Uh,
on the new environment?
Yeah, so Argo Rollouts is focused primarily on pods and the actual running containers. It doesn't do progressive delivery of config maps and secrets and those sorts of resources. It's designed specifically to replace the deployment. So really, how you interact with pods and expose that.
Okay. So let's, on that note, instead of saying what Argo Rollouts
There'll
is
be a lot of
not. Yeah, I bet. I've been fighting it actually for a while, and it's probably not the last time I'm going to do that. Um, Instead of saying what it's not, let's say what it is. Let's
yeah.
get a nice definition on the board.
So I'm going to start with a definition of the kind of higher level concept behind Argo rollouts, and then we'll get into how it applies to it specifically. So I want to talk about progressive delivery for a second, because
Ah, love it.
that's what we're missing. The
Okay.
standard deployment within Kubernetes does not provide progressive delivery of changes. Um, so progressive delivery is often described as the next evolution of continuous delivery. So it extends the benefits of practicing continuous integration and continuous delivery, but to the actual deployment process into the cluster. The After you've made that change, you can kind of think of continuous delivery as getting that change into the cluster, and the progressive delivery is the rolling out of that change after it's in the cluster. So to put
Okay.
it maybe a little more concisely for the board, progressive delivery is that process of releasing updates in a controlled and gradual manner, therefore reducing the risk of that release.
This couldn't have come at a more timely.
I know. I was writing my notes and I was like, how often do I make references to?
To current events as part of our thing. Okay,
Mhm.
the process of
Yes.
releasing software in a slow and controlled manner.
Yeah, controlled and gradual manner. And the primary focus of that is reducing the risk of the release, because that's really like everybody wants to move fast with their deployments. They want to get it in, but get
Mhm.
it into the cluster and get it out to their users because that keeps them competitive. But the
Mhm.
challenge is that you can't sacrifice safety and quality for speed. Speed actually comes as a result, and this is the research that they've done into DevOps practices is that safety and quality actually produces speed. You the faster and the safer and higher quality the changes are, the faster you can get them out into the hands of users. Um,
And like them getting out quickly is good, but also the fact that it's automated, it does mean like the cognitive load of actually getting it out there is you can be like, okay, button pressed, it's done, move on to the next task, and ideally it's just doing its thing.
Yeah, and you're by automating the process, you're continuously integrating the learnings from a failure into that process. If I have a failed deployment and I
Uh-huh.
didn't catch it because it went through my process, you do that post-mortem, you understand what was missed in the automated verification and deployment, you integrate that into the process, and then it's there
Uh-huh.
for the next time.
Yeah, beautiful. So this is, let me verify, progressive delivery is the process of releasing software and updates in a slow and gradual manner, therefore
Mhm.
reducing the risk. Cool.
Exactly. And so this commonly shows up in two different strategies, either blue green deployments or
Mm.
canary deployments. Those are the two that people are going to hear the most about as they start investigating progressive delivery. Um,
Does
so
progressive delivery, like everything, have an acronym?
I've never seen it described as PD anywhere. Like,
Because I
I don't
think
know.
police department, I think,
Right?
yeah, is too
Yeah.
even. um, so there are two progressive delivery strategies.
Yeah. The simpler one being blue green deployments.
Okay.
Blue green deployments are essentially having the new and old version of the application deployed at the same time. And so the new typically being referred to as green and the old being referred to as blue. So blue is
Mm-hmm.
your existing version, green is the new one that you're introducing into the environment. And so during a blue green deployment, only the old version, the blue, is receiving the traffic, the production traffic, but the green version is fully deployed alongside the blue one, allowing the team to test changes against the green deployment in production
Mm-hmm.
without it actually being exposed to the users. So you get it running in the production environment, but you're not
Mm-hmm.
taking on any risk because you're not exposing users to that version.
Okay.
So you can kind of think of green as like a preview environment that you're running alongside blue. And then so uh, that's the one that's the simpler version. Um, Canary is the more complex progressive delivery strategy. A canary deployment is when you start exposing a subset of users to that green version of that application. If I was to follow along with the same analogy,
Oh,
yeah, without sending traffic to it. Exactly.
okay. And so now we have canary.
Yes. So Canary, at least in my opinion, is the fun one because it's what actually enables the. I feel like it's more aligned with the progressive delivery strategy. So a Canary deployment is when you're explicitly exposing a subset of users to that new version of an application, while serving the rest of the traffic to the old version. Um, so
Mm.
you get the new version deployed alongside the old version, but now you're saying this subset of users based on whatever your parameters are, and that could be as simple as I want to give 5% of my users to the new version, And it can be as complex as I want only 5% of my Firefox users on Mac OS to go to my new version. And so that's that gradual progression. We start at 5% and then we move to 25, we move to 50, and then we move to 100 as we gain confidence in that new version of our application.
So gradually increase amount of users to the new app.
Mm-hmm. And during that progression of steps, typically in each step, you want to start analyzing, okay, what's happening to that 5% of traffic, that 25% of traffic that's going to my new version. And that's typically you're running some sort of analysis, determining, okay, I'm seeing the correct outputs, the correct metrics from my application, from my canary deployment exposed to that new subset of users. If I feel confident that I'm getting the correct metrics, and that confidence could either be you're doing manual testing or you're doing automated testing, you build up that confidence, and now you progress along that gradual exposure.
So you're observing, analyzing, and testing?
Yeah, you can. That's the really interesting part, is that you can simply observe what's happening and keep progressing that way. You can actually do deeper analysis based on your metrics, or you can do straight up testing, integration testing against that new version, and you can do all of them at the same time, even, which is just like, how complex do you want your testing to be, basically. So
We have
that's the
I
theory
have a
side.
question. We also have a couple of nice comments in chats that we have such a flow, is what Gan Attack says. Awesome. I give Nick all the credit. And then Daniel says, classic canary in the coal mine. Is that why it's called a canary deployment? It's got to be, right?
Yes, yeah. That's I should have given some background on that. It's that idea of like you're waiting for signals to see if there's a problem, and then being able to act on that signal. If the canary stops singing, then you need to react. And typically canary deployments are like, you want not only the progression to be automatic, but you want the rollback to be automatic when you recognize that there's a failure in your progression. So to talk a little bit about in comparison to blue green, when you
maybe you're going to answer my question. Okay. You go first.
When you do the blue green, the idea is that you keep the blue version scaled up for some period of time after switching over. So it's kind of a hard swap, usually at a load balancer to go, okay, I want to go to my green version, my new version, send all traffic to there, keep the blue version running for a little while in case we need to do a quick rollback. And then you can simply just switch it at the load balancer, and there's no additional spinning up of infrastructure. There's no delay in that transition to the old version, and that improves the safety of the release.
So when you do a blue-green deployment, and this is close enough to my question, what you do is eventually you switch all traffic. There is like a moment where you're just like, bam, we're doing green now.
Yeah, it's like a button press. You're like, okay, now it's this one. And that's the primary distinction, is it's not gradual. You might see some people talk about gradual blue-green deployments, but at that point, they're really talking about canary deployments, but just started with blue-green.
So I have another question. They don't seem mutually exclusive. Seems to me like you get a second one running, make sure it looks good, and then use the canary method to slowly get traffic.
You certainly, at least in theory, you could, and in practice with Argo Rollouts, you can, though it makes a clear distinction in the resource used to implement progressive delivery between those two strategies. But you could, in theory, deploy a canary where it spins up 10 pods but doesn't expose any traffic to that new version, and then you can start stepping through the progression after you've done your initial testing on kind of the preview.
Okay. We have a question. How does the horizontal pod autoscaler behave in these two different types of deployments?
Yeah.
Progressive delivery strategies.
I am not certain, honestly. I'm pretty sure that it. Let's see. So the HPA will. I think actually Argo Rollouts might be able to integrate with the HPA to say. Um, oh yeah. Okay, okay. I'll go on a small tangent about HPAs. When you're running a horizontal pod autoscaler, you can set the target reference for how to scale, and the rollout resource that we'll talk about in a moment actually becomes the target reference for the HPA. So it pulls information from the rollout resource to determine how to scale the pods. So you start referencing it as the source of truth for when to scale versus CPU metrics or other things. Actually, I guess you can. I think you can do both, but I'm not an expert on the HPA side of this. I'll admit, but it's a very good question because typically you'll want to dynamically scale the number of pods for your application, but you also want to progressively deliver. Um, yeah, so I think it can take the information from the rollout into account.
So I feel I'm having a great time. But I feel like I've used up over half the board and we still haven't even talked about what Argo rollouts is
Yeah,
exactly.
we can get to the good stuff now.
I feel a little guilt. Okay. So we talked about how Kubernetes does it and Kubernetes shortcomings. We talked about progressive delivery and progressive delivery strategies. And now let's talk about Argo rollouts.
Yeah. Now we have all the context and we have the background to make Argo rollouts make sense.
Uh-huh.
So Argo rollouts is a controller that runs in Kubernetes and a set of CRDs which introduce these advanced deployment capabilities, the progressive delivery strategies like blue green and canary to Kubernetes. So all of the functionality that we've talked about that progressive delivery provides, Argo Rollouts is the controller and set of CRDs that implements progressive delivery into Kubernetes or
Would
provides.
would okay. Is a controller and set of CRDs, which stands for custom resource definitions.
Yeah, that's important to include. It provides custom resource definitions, which introduce a new resource type into Kubernetes that you can then create instances of that new resource type.
Mm-hmm. Okay, and then what's the rest?
It's a controller and set of CRDs that introduce progressive delivery functionality into Kubernetes.
I'm gonna say add.
Yeah.
Cool.
So, for people that are probably looking at Argo rollouts, they probably also heard about Argo CD. You can think of Argo CD as it provides the continuous delivery of changes of Kubernetes manifests into the cluster. However, that only updates the desired state of the resource. You can kind of think of Argo CD as updating that desired state. And then Kubernetes is then left to its own devices to modify the live state to roll out that new desired state. So Argo rollouts is that layer after Argo CD has changed the desired state. Argo rollouts then allows the granular control over that transition from the existing live state to the new live state.
So for those of us who have Argo projects, um, definitely hard associated with GitOps.
Mm-hmm.
Is this have to be used with GitOps or is it its own thing completely?
It certainly doesn't have to be alongside GitOps. They complement each other well, but really all you need is deployments running in Kubernetes or the intention to run deployments in Kubernetes to be able to take advantage of Argo rollouts because it's you could simply modify the desired state with kubectl apply or kubectl edit, and then Argo Rollouts can still do that progressive delivery.
I mean, I'd argue that any additional functionality added to Kubernetes would go well with GitOps.
Exactly. Yeah.
All of it complements GitOps. Does Argo Rollouts complement GitOps any more than any other custom resource that you're adding to and deploying with?
It like I think there's an argument that it does because GitOps just makes the change and then it lets Kubernetes figure out how to roll out that change into reality, because GitOps is
Uh-huh.
all about just progressing that desired state. Argo Rollouts is like another layer of functionality that gives you control over, okay, how do I want that to be changed
Okay.
in the live state of my cluster,
All right. Okay. Yeah.
but only for deployments and pods. It wouldn't
Yes.
progressively deliver your config map to a subset of resources.
Awesome. So then what do you think is the best way forward from here? What do you want to talk
Yeah.
about the different custom resources? Do you want to
Yeah, I think
what
that's the best option. We'll talk about, so like it's a controller. You can just think of that conceptually. We don't have to go into too much depth there, because what most people are going to be interacting with is the rollout custom resource and the analysis template custom resource. So we'll start with rollout, because that's the most fundamental piece here. Is the rollout CRD is a drop-in replacement for the deployment manifest. So if you're already running a deployment, you can swap that out with a Argo rollout resource. I guess it's a rollout resource that's owned by the Argo group. Um, but that rollout CRD is going to replace your existing deployment resource to be able to add in the progressive delivery functionality when making changes.
So what's the first one called?
A rollout.
That's makes a lot of sense.
Right. Yeah. It's like Argo
Rollouts.
CD having an application. It's they went with very apt names.
Sometimes it's too good though, and that in itself is confusing. Okay, so with the rollout custom resource, what functionality are you adding to your cluster?
Yeah. So with the rollout custom resource, you're replacing your existing deployment resources
Ah,
and adding in the progressive delivery functionality, the ability to do blue green, the ability to do canary, and traffic routing and analysis and advanced promotion, which we'll get into in a moment.
that feels okay. Maybe it just like feels a little scary, like I'm attached to the deployment.
Hmm.
And also maybe I'm this whole current events thing, the CrowdStrike has
Hmm.
scared me. And I didn't care about blue green and canary deployments, but now I do. But I
Hmm.
already have tons of stuff already running with Kubernetes deployments. Do I have to rewrite all my configuration and everything if I want to add? Is
I don't think so. I think the idea of it being a drop-in replacement means that you can
uh-huh.
simply change uh, the the like API and the kind on your existing deployment resources to now reference an Argo rollout
Mm-hmm.
resource. So that's that like drop-in replacement idea, is that I already have this existing deployment running. You can add
Mm-hmm.
in, you can either swap it directly and it'll take ownership of the pods, or you can create an Argo rollout resource and have it reference an existing deployment. And then as you go to do your next rollout, your next change to that rollout, it'll
Uh-huh.
actually scale down the old deployment and bring up the new pods
Ah.
using its whatever delivery configuration you put on it. So you can do a canary deployment from your existing deployment resource to the new rollout resource.
Okay. Awesome. So so there are some good options to be able to replace your deployment resources with rollout resources.
Yeah, it's definitely designed to be seamless because it would be kind of hard to drive people to adopt it if they could
Yeah.
only, do greenfield deployments on it. Um, and so like the
Yeah.
rollout, actually maybe I'll save that for a moment. So the probably the other key resource here.
Wait, I'm not done talking about the rollouts. I have
Okay, yeah,
questions. Well, first of all, I want to find a succinct, I think I'm going to use this space right above my head to say something about how it's easy to switch from uh, deployments to rollouts. There's some
okay,
good, yeah,
yeah.
maybe
So
it's that easy. Yeah.
maybe we can put it succinctly like you could do it's a drop-in replacement for
Uh-huh.
the deployment. So
Okay.
simply, believe you can simply change over the deployment. Um, so like you would change the when converting a deployment to a rollout, you would change the API version and the kind from apps and deployment to Argo Project and rollout. And then it would essentially take over ownership of the existing replica set. It would, I think it migrates it live. Uh,
I,
it would, yeah.
I wrote it's easy, which I know no one ever wants to actually say that. And I'm going to say you said it. Look, it's on the board. Therefore, Nick
Yeah.
said it.
Come find me and tell me how not easy it is later. Yeah.
Nick says. um, and then the other thing, what we kind of just said is it adds additional functionality.
Mhm.
I want some like examples. I want to
Yeah.
understand that better. Yeah.
Okay, well, let's go a little into depth on what the rollout actually does differently from a deployment. So
Okay.
it introduces deployment strategies to creating new replica sets. So like if we as you can see in the top corner over there, we talked about how a deployment creates replica sets, creates pods. The
Mhm.
rollout resource introduces new functionality on how it progresses from old replica set to new replica set and distributes traffic to those new replica sets. So
Mhm.
to get specific about it, if we looked at like the blue green deployment strategy,
Uh huh.
the important distinction there is that a normal deployment will only control changes to a replica set. The rollout resource running a blue green deployment strategy will also be able to make changes to the services that uh, serve traffic to those
Oh.
pods. So the rollout spec will
Uh huh.
reference an active service and optionally a preview service. And this is for blue green to
Ah.
keep that in mind. So the active service is whatever the running version, the one that you want to serve live traffic to,
Uh
it
huh.
has that active service. And then you can specify the preview service, which is how you would be able to get access to that green deployment, that new version,
Uh huh.
before you've exposed it to the production traffic. And this rollout resource takes responsibility for actually making the changes to those services as it progresses the change. Um, so let's take an example. I have a new version of my application. I've got V2, and I want to do a blue green deployment. I
Mhm.
already have this active service, and that's sending traffic to the blue version of my application, V1. I make a change to my pod template to reference V2 container image. That generates a new replica set, and the rollout is going to create that replica set, spin up the green version of our application V2, and then it's going to configure the preview service to send traffic to that green version. You can now access it outside of the production version of the application, and then by default, the default behavior is that as soon as the pods in that new replica set, in our green replica set with version 2, are ready and available, like the standard Kubernetes concepts of ready and available for pods. Once all the pods in that replica set are ready, then it's going to switch the active service to reference that new replica set, that green version, and it's going to do that switch over for you.
Mm-hmm.
So yeah, how do we make that
Very
concise?
simplified. Argo, the rollout resource can create and manipulate Kubernetes services
Yeah,
objects.
and it can have
And
an active and a preview one for blue and green.
and those services control traffic splitting was all I was going to put. But okay.
Yeah, well, yeah, it does, and that's the most basic version of traffic splitting in for Argo rollouts. We'll probably have some space left to talk about traffic management, which is an important part of this.
For blue green there.
Like active
Yeah.
preview services.
Yeah. The word service, I want to be like Kubernetes service object. Or like the word service can mean microservices. Like sometimes you say service when you mean like little application, and it's just a hard word. But
Yeah, like capital S or
yeah.
SVC might get people thinking about Kubernetes.
Okay. Okay. An active service and a preview. Okay. I'll make this a capital S. So, so maybe, is there anything else you want to say about the rollout object, or do you feel like this is a good example and we're happy about that?
Yeah, I think we still need to describe what the canary deployment strategy is for an Argo rollout. And I think
Okay.
briefly, actually, it would be good to mention that the other kind of high level conceptual functionality that the rollout adds is the ability to do analysis as you go through the progressive delivery. So it can manage how pods are rolled out in a more precise manner, but then it can also do testing and verification against that rollout. So this is the analysis. It's kind of hard because I have to describe the analysis template to be able to describe that the Argo rollout uses the analysis template. But maybe just conceptually, we can say that the rollout resource does analysis as a part of the delivery.
So, are we going to talk about how it does canary, and then maybe I'll write down about analysis?
Yeah, let's do canary first, and then we can
Okay.
add in analysis to those concepts. Because yeah, it'll be pretty easy to see where they fit in.
Okay.
Okay, so a canary deployment strategy on an Argo rollout.
Mm-hmm.
There really is no agreed upon standard for what a canary deployment is. There's no project out there saying that you have to do 5% traffic before you do 25, before you do 100.
Uh-huh.
It's really up to the organization to determine like what does canary look like for us.
Okay.
So the Argo rollout resource simply lets you define a list of steps that the controller will use to determine how it's going to manipulate the replica set as it progresses through the delivery. So simply the canary is a list of steps that the rollout is going to follow to progressively deliver that change.
Okay.
And so in each of those steps, you can set two fields. You can set
Mm-hmm.
the weight, which dictates the percentage of traffic that should be sent to the canary version, that new version that you're giving to a subset of users. So you can set the weight, which is
Mm-hmm.
percentage of traffic, and then you can also add in a pause, which pretty obviously says how long the canary deployment should stay at that step in the canary deployment. So wait is that percentage of traffic that we want to send it to, and pause is how long do we want to spend on that percentage
Mm,
of traffic. And that wait could be a time, or it could also be indefinite, saying I want to be at 5% until somebody tells me
mm-hmm.
not to be at 5%.
Mm. Uh, could be time-based or event-based.
Could be time based or indefinite for the pause instruction. It's either uh, as long as
Yeah.
you set it to be, or until you tell it not to be paused.
So that's what I was calling an event. But
Oh, an event.
okay.
Oh, I see what you're saying. Like you trigger an event, and that event is like removing the pause for that step, right?
Yeah.
Yeah,
But
yeah,
I'm
okay.
just gonna leave it. I'm just not gonna say anything. We
Yeah,
have
that's perfect.
a long question. I wanted to let's get to it. Is it mandatory to have Argo CD and rollout at parallel?
No.
No. We already I already asked that question. Or can we use rollouts as a single entity? Um, but let's see if there's something else you want to speak to. If both are there, who will handle the deployment? Will there be any conflict as both offer the same functionality, resulting pod restart and loop, where rollout is having much more functionality with deployment strategies? Rollout will
Uh,
override the Argo CD. So based on my understanding for what Nick's just taught me is the rollout will completely replace the Kubernetes deployment. So therefore those two things are not in conflict anymore. So if you have both running, Argo CD is going to act just like it does. It's going to pull the changes from Git and apply those changes to the cluster. But in this case, it's implying what it's deploying to the cluster is an object, a resource called a rollout, instead
mhm.
of deploying a deployment, a Kubernetes deployment.
Yes,
Is that
and
correct?
there's maybe like an asterisk there during the like
Okay.
migration phase, where if you're deploying the deployment with Argo CD and the rollout with Argo CD, like you're doing a migration instead of a drop-in replacement,
Uh huh.
if you haven't left enough room for imperativeness, so say you're explicitly setting the number of replicas on the deployment in Git, and then the rollout is changing the number of replicas to do that migration to the new version, you might run into like source of truth issues there and start getting some ghosts in your cluster. But the I that's more of an edge case than it is a functional problem. So yeah, basically
Th-
it Argo CD delivers the change. The rollout is going to make the change in the cluster or deliver it. Yeah,
Thank you so much for your question. It helped, and thanks, Nick, for letting me answer it. It helped me solidify the concepts that you've been teaching me. So
great.
that's cool.
Okay. So we have our rollout. We have our two strategies that the rollout can introduce.
Uh huh.
Um,
And then
is
there was the thing we were going to come back to about a rollout, which I forget what it is now.
Yeah. Now, I think now we
That
can get on.
the verification.
Yes, exactly. So now we have to talk about these have been very simple examples of we can do the progressive delivery based on time and percentage of traffic. But there's actually the next step of that doesn't ensure safety. There's no automation involved in that process. You can't automatically verify, okay, how do I want to determine that my application is safe now that I've exposed it to 5% of my users.
Mm-hmm.
um, this is where the analysis template comes in. So the rollout is the core custom resource, and the other
Oh,
custom resource that at the core of this is the analysis template, which the rollout can take advantage of.
got it. So the big thing about rollouts are they add these new rollout strategies.
Hmm.
And and then the verification part is going to introduce a whole new custom resource.
Yeah, yeah, which adds another layer of functionality to the rollout.
Okay, that the rollout can use. So therefore, am I going to write about it in the rollout? Uh,
Probably
Yes.
alongside of it, and then we'll probably have some
I'll
arrows
leave.
that point to, where we would use it.
Okay. Let's just go for it and we'll make it work.
Okay.
A story of my life.
We're doing it live.
Uh, so what's the second custom resource called?
Okay, so an analysis template is what will be, and that's, capital A, capital T, one word. So our rollout can reference analysis templates. And this analysis template, uh, what it does is it defines how to do analysis on our new version that we're rolling out with the other resource to
Mm-hmm.
determine what success or what failure looks like for that rollout. So the
Mm,
Argo rollout has no concept of like what is a success metric for this this step in my canary deployment for this 5% of traffic. The analysis template adds in this concept um, of analyzing metrics from providers to determine that success or failure.
okay. Um, this is a nit of a question, but is it always going to reference analysis template? Or does it have to use one, or is there
It
ever a
does
use case?
not. It can
Okay.
actually do it independently, and it provides a very bare bones approach to progressive delivery when you don't introduce analysis templates. So it's better than the rolling update and recreate strategies of a deployment, but it doesn't provide the sophistication to really make it a safe rollout. You're kind of assuming that all the analysis, the testing, the integration, verification is happening manually by somebody else outside of the
Okay.
cluster. This
Uh-huh.
analysis
Good
template
one.
allows you to codify that and make it happen automatically.
That's that's the manually and someone else. I don't like either of those things.
It's awful.
Um, I guess manually and me is worse. If it is going to be manually, at least it's someone else. So a rollout can reference an analysis template, and an analysis template is.
Yes. So an analysis template is a specification for the the providers that you want to pull metrics from. So a provider could be Datadog, it could be Prometheus, New
Here's
Relic.
where the observability comes in.
Yeah, this relies on your observability infrastructure to be able to do that safe progressive delivery.
So
So
when we say providers, can I say it references an observability provider?
yeah, yeah, that would be apt. It can reference an observability provider, which Prometheus, Datadog, New Relic, all fantastic examples of that. Uh, but you could, in addition to your observability provider, or instead of, you could actually even reference a Kubernetes job or an HTTP request that you want to make. So you don't have to rely on these external providers to provide your metrics. You could just run a job in the cluster that does literally whatever you want, and then based on the success of that job, it determines the success of the rollout. Similarly, with an HTTP request, you could, if you get a success request or the desired response from your HTTP request, you can determine success or failure for that analysis.
So it can reference observability providers. What else can it reference?
Kubernetes jobs or HTTP requests. Those are the big three.
Okay.
Which you could probably lump Kubernetes jobs and HTTP requests into one bucket of like run tests almost.
Okay. So it references those things and it gets information from them that does what?
That determines the success or failure of your rollout. So this could be a number of things. The success, you basically you write a success condition, and then you write you specify a failure limit. How many times am I willing to not hit that success condition to
Mm-hmm.
consider this rollout or this analysis failed, let's say. Um, so yeah, you specify success condition, failure limit, and where you're pulling your your metrics from, your providers. Basically, those are the main three things in an analysis template. Oh, and the interval at which you poll for that success rate.
Okay. I'm just gonna. Providers isn't quite right. From where to get
Yeah,
metrics?
your metrics. Yeah,
Okay.
success condition, failure limit, and metrics. I think that's apt. And
Okay. And you.
interval.
Uh huh. And pull interval. Scrape interval.
Yeah,
Pull.
poll maybe. How often you
Okay.
poll for the metric? Yeah,
Poll instead of
yeah.
Pull. That that got me during the Argo CD episode too. Um, so I still am wrapping my head around this. I get that there's somewhere external that's observability. Let's just say observability and leave out the edge cases to keep it simple. So
Mhm.
I'm reaching to Prometheus to get metrics that, and then those I've received those metrics and they satisfy my success condition.
Mhm.
And so therefore, then what happens?
Yes. So here's the important part is that our rollout is referencing an analysis template, and
Uh
when it
huh.
goes to do an analysis when it goes to do a progressive delivery of when it goes to do a rollout, let's say, to keep the terminology consistent, when the
Mm-hmm.
rollout goes to do a rollout, it can do it can create an instance of the analysis template to go and run that analysis against the rollout. um, so there's a couple different ways it can do this. Um, so let's go into the example of we have this rollout. We've got a new version that we want to deploy into our cluster, and we're
Uh
doing
huh.
a canary deployment. When we do our canary deployment, we specify steps that we want our canary to go through
Uh
to
huh.
gradually expose to new users. The analysis template can be used in a couple different ways. You
Uh
could
huh.
run a background analysis, which during the whole progression of the canary, as it's going through all the steps, this analysis is running in the background outside of those steps, kind of in tandem. You're going through your canary steps and you're also running your analysis alongside it. So it's not tied to any one step in the canary process. It's
Uh huh.
kind of happening at the same time. The alternative to that is being able to run the analysis in line. So you're saying, when I reach this specific step in my canary deployment, now I want to
Mm-hmm.
run this analysis, and I'm not willing to progress past this step in my canary deployment until this analysis is successful. So you can, does that make sense?
So um does the like are you saying the rollout triggers the action of the analysis template to happen? The
Yeah, it
poll
creates.
interval?
Yeah, exactly. It creates so technically, on the technical level, it's
Uh-huh.
when you run a version, an instance of the analysis template, you're creating an analysis run resource. So that analysis run is an instance of an analysis template that actually went and did the thing. It pulled for metrics, it determined success criteria, it had a result. Um,
Then I
so
don't understand the poll interval in the resource if it's being triggered from the rollout.
Right. So the when you run an analysis run, or I guess when you create an analysis run, it's going to run that determine that success criteria. So it's going to pull from the provider, determine if it's successful, and then with the interval, you're saying, okay, now in another 5 minutes, do that again, and you're saying, okay, in another 5 minutes, pull that success criteria again, and then once you hit your let's say time out, your count, you said like, okay, I want to every 5 minutes pull from this provider and determine if it's hitting my success condition. And I want to do that
Mm-hmm.
3 times. And after I've done that 3 times and I've got successful 3 times, finish the analysis run and call it successful.
Okay. So an analysis template or an analysis run, which eventually it will be declared successful, success or failure.
Yeah. Eventually, so the analysis template generates an analysis run, or really the rollout generates an analysis run based on the analysis template. And then that
Uh-huh.
analysis run completes and is either considered successful, failed, or inconclusive. And based on that result from the analysis run, it changes what the rollout is going to do.
Okay. So
It might be good to branch off analysis run and say like there's 3 end states of an analysis run. There's either completed or sorry, there's successful, failed, or inconclusive, and then
uh-huh.
that's the information. Because like the rollout doesn't actually care what metric you're polling. The rollout cares when I did this analysis, did I get success, failed, or inconclusive, and then it uses that information to determine what to do next in that progressive delivery.
I understand that. I would like to so we have analysis run here and I will get those three, like it's going to resolve into one of those three things. But
Mhm.
before I do that, I kind of want to figure out how does an analysis template, how does it relate to an analysis run?
Right. So the analysis template is the template for what the analysis run is going to do. So the
Okay.
rollout references the analysis template and creates an analysis run based on that. So really, you're just creating this reusable set of success criteria and metrics that can be used by rollouts, like rollout resources during their progressive delivery.
Okay. Does. I'm just going to write does. And then so we can zip up analysis template. We got it here, right?
Yes, I think that's a good enough summary of what the analysis template's going to do.
Good enough. My favorite. We'll
Given the
take
amount of
it.
space we have left, I'm sure I could fill a full board on analysis templates, but uh,
So we have analysis template, and then now we have more rollout stuff. So a rollout references an analysis template to make an analysis run. So
mhm.
now I'm going to go take this up here.
Yeah, so it references the analysis template in the deployment strategies, in the blue green, in the canary. Does that make sense?
Yes, I'm my brain's turning less about whether it makes sense and more about
How to
how I want to represent it here. Um, uh, in strategies. Cool. We'll see. When I do the recap, we'll see if this is syncing in. But I
yeah.
think it is. So in the strategies, an analysis template is referenced that makes an analysis run.
Mhm.
Analysis run. An analysis run is a custom resource, right?
Correct. Yeah, it's a separate
It's
resource.
like it's like yeah, almost like analysis template's a class and then analysis run is an instance.
Yeah.
Because
It's the same way that like I know there's good, like, if we were looking at like crossplay, it'd kind of be like how you have your grouping of what resource should exist, and then you create an instance of it, and that's what actually generates the resources. Or it's kind
success.
of like a cron job resource has a job template, and every time the cron job runs, it instantiates a job resource from that cron job.
Oh yeah, okay. Yeah. Like it.
Okay, so our rollout it's got a new version, it's trying to get it into the cluster, and it's trying to do it safely. And it's
Uh-huh.
using these analysis runs to determine what is safe and what is successful for our rollout.
Uh-huh.
Um, if we hit our success criteria, the rollout will continue on with whatever's next in the delivery. So success is we're great, everything's working as expected. Continue. It's literally like having a continue statement in a for loop.
Mm-hmm.
Um, the fail condition will tell it to abort the rollout and actually roll back to the previous state, to the original version from
Mm.
before. So success, we continue on. With failure, we roll back. And then there's the inconclusive, which actually can tell the rollout to pause and wait for further instruction for
Oh.
manual intervention. So and so that could be, we pull some metrics from Prometheus. We're seeing, 95% success rate in our HTTP codes, or we're seeing a standard, like our expected level of success for our calls. We continue on with our
Mm.
rollout. We're now seeing a ton of new 500 errors in our HTTP codes, 500 responses. We'll consider that failed. It did not hit the success criteria in the number of intervals, and we've hit our full count or our failure limit. Abort the rollout and actually do the rollback, like stick to the prior version.
Mm-hmm.
And then inconclusive, pause the rollout, wait for manual intervention. Just stop where you are. So if we're going through our canary analysis, we could be at our 25% traffic being served to the new version. We get an inconclusive result from our analysis run, which could be, hey, Prometheus isn't available right now. I can't pull my metrics. I'm not sure what success or failure is right now. Wait for somebody else to come by and tell me what to do. That's where inconclusive will get us. Um, I'm trying to decide whether or not to go down analysis templates a little bit further to say where we use them, or if we should start talking about traffic management with our little block that we have left.
I uh bef- I have a question. Is this like what normally happens, or is this um like if you, I don't know why, but what if for some reason success means you want it to mean rollback? Or if it's successful, wait. Like are these like tied or
I
are
think they are tied like one for one. So
okay.
you would modify your analysis template to say my success criteria is to see enough 500 codes that we're actually breaking it, or something. Like you would play with that on the
Okay.
template side and the criteria, not on the status codes.
Okay. That makes sense. All right. I can't help you in terms of how
Yeah.
you want to use this
Let me.
traffic or
Yeah. So I think it is important. I think traffic management is probably another key important concept. I'll just talk a little bit about analysis runs and how it gets used, and then
okay,
we
but
can
I won't
start
write it
writing.
down.
Yeah,
Okay.
yeah.
And then when we talk about traffic management, are we talking about custom resources still, or are we talking about something else altogether?
Uh, it's. I don't think we're going to be introducing any new custom resources. We'll just be talking about how the rollout can interact with traffic management solutions.
Okay.
Um, so probably an arrow back to rollout somehow through other arrows.
Okay.
Um,
Got it.
so uh, just to talk a little bit about using analysis templates in rollouts, conceptually, there's like two different ways for both deployment strategies. For canary deployments, you can do it in the background to say, I want to run my analysis while I go through the steps separately,
Uh-huh.
or you could do it
Yeah.
inline to say
Okay.
that on each canary step, I want to run you could run different analysis as you go through. When I'm delivering to only 5% of my users, just do a
Mm-hmm.
simple smoke test. When I'm running at 75%, maybe let's wait a little longer and collect more and more metrics. Like maybe over the next 3 days, we just collect metrics and test
Mm-hmm.
it before continuing on to 100%. So,
Oh, okay.
right. So
So
as you
like
get, mhm,
like running it inline is like, hey, we just need like a little taste of like what's going on that we can just get right in this moment, and then after a little snack, we're gonna keep going. And
mhm.
versus in the background, like it's like Thanksgiving, we're spending all day cooking, we're not gonna eat anything, and then when we need to like go in and when it's time, we have a whole feast to be able to decide, make a decision with what we're gonna do.
Yeah, yeah, that's definitely like that's one way to look at it. Maybe the other way to look at it is
You're so
like,
nice to me. You're like, sure, Whitney,
sure.
pat me on the head.
I would say it's like having the analysis run in line is kind of like having stoplights as you progress through down the road of your delivery. You hit an
Uh-huh.
intersection, you're on a step of your canary deployment, and that analysis run is going to give you the green or red light or yellow. I'm not sure, the
Uh-huh.
inconclusive result, but it's telling you whether or not you can continue forward down the road, down the delivery, where
Uh-huh.
the analysis template running in the background is kind of like having a cop sitting alongside the road saying, he's going a little too fast, stop here, even though it's totally independent of the intersections.
Oh, okay. So it's not a matter of, so the analysis running on the side has the ability to say at any point, this isn't good, stop it.
Yes.
As opposed to in the, and has like maybe deeper metrics to pull from because it has some sort of history of what it's looking at, but
It could be,
that doesn't really matter. It's
yes,
more a matter
size.
of,
Mhm.
okay, so I was misunderstanding by thinking the one running in the background was keeping some sort of historical or like a deeper performance,
Right.
and
Yeah.
that's
No
not
more
right.
so. Yeah. Like it could. That's an option that
Uh-huh.
you're allowed to do, but not intrinsically as a part of its design. The analysis template can be as simple, complex, long running or short running as you want it to be. And then you can use them in either situation. You could have a really short, simple background one, or you could have a
Uh-huh.
really long running background one that takes you, weeks to get through. Or you could have
Okay.
really short ones inline and have a really long running background one, or really short background, really big inline one that pauses you at one step
Ah,
for a really
okay.
long time, collecting a bunch of metrics.
But the
Okay.
point is the inline one can only talk when it's asked. And
Yes,
the background one, it can like jump in at any point and interrupt anybody.
exactly. Yeah.
Okay, got it.
Yeah. It's not constrained to that particular point in the delivery. Yeah. So that's Canary. And just very briefly, for blue green deployments, you can basically
Uh-huh.
do the same reference to an analysis template, but it happens either before you do the promotion, before you switch over from blue to green, or after. And it's pretty much just that simple. You either run your analysis and both. You could do both. You can do your analysis on the green before you expose production traffic, and then switch it over
Uh-huh.
at the load balancer. And now let's test it after people are running on our
Okay.
production. So you can be like, smoke test, no traffic's going to it. We still look healthy. That's great.
Uh-huh.
Okay, now let's throw it in the fire and see what the result is, and you can kind of compare the two.
Okay. So
So
this success fail inconclusive, is that only for Canary or is that
that's for blue green as well. So you could
okay,
say
so I see.
my pre promotion analysis run on a blue green
Mm-hmm.
failed. Yeah, no need to switch over to green. We already know
Okay.
something's wrong.
Okay.
And if it's inconclusive, it's like I'm still willing to progress, but you have to tell me to do it.
Okay. Call. Got it. Um,
Okay.
all right, traffic splitting, traffic
Traffic,
management.
yeah. Yeah, so now this is like the last really key concept to understand is that um okay, so I'll talk a little bit of context and then I can get into it. So
I love
when you
it.
services. So we talked a little bit for blue green having an active and preview service. Actually, that's tangential. So we have a service, and it
Uh-huh.
uses selectors to determine which pods to send traffic to. This is like kind of core Kubernetes functionality. Is you tell it which pods should be receiving this traffic. A standard service, you can really only split traffic and manage the split of the traffic based on those selectors. So you've got
Mm.
5 pods, and I say 20% of I want 20% of my traffic to go to the new version. That means I need one of
Mm-hmm.
those pods to be on that new version because that's 20% of the pods. So you're limited on your granularity
Mm-hmm.
based on how many pods you have, and then you can set weights, but you're stuck trying to find whole numbers for the number of pods you want to send it to. So this is why Argo Rollouts introduces more sophisticated traffic management by relying on other service meshes, by relying on things like AWS ALB, Istio, Gateway API, Trafic, Nginx, Ingress. It
Mm-hmm.
can use those to do more sophisticated traffic management during the rollout. Um, so what this does, so to say it concisely, like the core Kubernetes objects don't give you that fine-grained tooling to manage traffic. Uh, at most, it's going to offer load balancing capabilities through that service by saying, okay, I'm routing to all the pods that have this label, and some of the pods with that label are my new version. Therefore, you're kind of accomplishing load balancing. Um, but you have no functionality for like that's just basic traffic splitting. But what if you want to mirror all the traffic for production to both versions? You want to give the real production traffic to your green or your blue version, but then send a copy of that production traffic to your green version, but discard the response. So you just want to send it and see what your service does, but you don't actually want to serve the response to your users. So you're mirroring the traffic to the two versions. Or you want to do something like header based routing, where you want to put something into the data that you're sending to your service to say, if you receive this data in my request, send me to the new version. If you don't get this data in the request, like send me to the default path, the old version. So these are like the advanced traffic management techniques that people want during their progressive delivery.
Oh, before I write down that, will you restate? Like you said, it uses meshes or traffic,
Yes. Yeah.
or
Yeah. So
yeah, uses networking, plugs into networking technologies.
yeah, it
Or
plugs into like most succinctly, it's manipulating service meshes, integrates with service meshes
okay,
to provide that functionality.
does it work with Cilium?
That's a great question. Let me
Does it
see if
work
that
with
is.
sidecar models only, or
Let's see. Is Cilium one of the listed? I don't think so. Though
okay?
that doesn't mean that it doesn't exist. It just means that it might be a plugin, not a like first party supported ones. But you can think of like Istio and Trafic are really good examples of well known service meshes that have
Mhm.
first party support in the Rollouts project.
Um,
So we uh, we use traffic management functionality to be able to either do routing based on data in our request. So this is called header based routing, where you
mhm.
send a request with a specific header, and then that based on that, the service mesh or Argo rollouts instructs the service mesh to send that traffic to the new version.
Okay.
And then the other good example is being able to mirror traffic to the new version. So you're actually sending traffic to both versions, but you only care about the response from the old version for actually serving production traffic, but you're monitoring the application's response to that traffic, the new version's response. So header based and mirrored traffic.
Traffic mirroring?
Yeah, traffic mirroring. Yeah. So the Argo Rollouts controller is aware of these service meshes. You configure it to know that you're working with Istio with Trafic, and then the controller modifies that service resource that is being controlled by Istio to say, okay, these are my canary and stable replica sets. Here's where you should send the traffic to, and can adjust those services using the controls provided by that service mesh to implement this
Okay.
advanced traffic management.
So, would you? I'd love to hear like, here's a real world example of a canary deployment and how like that includes traffic, an advanced traffic management situation, and maybe can touch in all the other things we've learned about.
Okay, let's see if I can do this. We've got some web-based. I've got a guest book. I run a guest book application like everybody does on their Kubernetes cluster because I have Airbnb or something, you know.
Okay.
And I have this new version of my guest book that provides this new functionality. You can now use dark mode on my guest book, and
Okay.
that's the new version. But I'm a little unsure if how good this is going to perform on Firefox on macOS specifically. So like I've tested it in most places, but I'm a little unconfident about all of these different versions of Firefox and whether or not dark mode will look good on it. I have my Argo rollout, which is deploying my pods and referencing my container image. I've got a new version of that container image, and I've set up my steps in my canary deployment to say expose my application to 5%, 25, 75, and then 100. I've got 4 steps I'm going to go through.
Uh huh.
Um, so I trigger that change in GitOps. Argo CD syncs it into the cluster, and that's
Uh huh.
triggered the rollout to start the progressive delivery of that change.
Okay.
I um, I go through the first step. It spins up the new replica set, which brings up my
Mm-hmm.
new set of pods. And because I've specified a 5% weight on my first step, it's going
Mm-hmm.
to attempt to send 5% of the traffic to the new version.
Mm-hmm.
Um, but let's say I have a really popular guest book, because to be at this granular, you need a decent amount of traffic for it to work. But just hypothetically, 100,000 people are leaving notes in my guest book every minute, and so I have advanced traffic configuration to say I only want the headers that say that they're running the browser Mozilla, Mozilla Firefox, and there's a header in there indicating the OS type is Mac OS. So
Okay.
I 5% is the weight, and then my traffic management is saying only headers of this type should end up at the new version. So really, it's 5% of the traffic that have these headers are going to end up at my new version.
5% of overall traffic is
Yeah.
being examined, and then of that traffic, whatever has the right headers is going to the dark mode.
Yes. Yes, I
Okay.
believe so. This is actually, like, to eyes wide open go into Argo rollouts. This is one of the challenging parts, is mixing and matching all of these different options so that you don't
Yeah.
accidentally end up saying, I want 10% to be the new version, but I'm actually saying I want 90% of the traffic to go to that 10% that's the new version. That's a very common mistake people go through,
Oh,
is
okay.
getting the numbers right. So testing is really important here, making sure that you're actually seeing the desired result during your rollout, because you can
Uh-huh.
easily say 90% of my traffic should go to a version of my application that's only scaled up to 10%, and then you just crash it because you've sent so much traffic to such a small scaled version of your application.
Ah, okay.
So there are some realities to running our rollouts. There are some sophistication, but to continue on with the example, 5%
Yes,
has
I
gone
love this
to
example. Uh-huh.
it's yeah, let's see how deep I can go into it. So, 5% of overall traffic is being examined, and only
Uh-huh.
the ones that have the Mac OS and Mozilla Firefox headers are going to it. And
Uh-huh.
then I run an analysis run on that step saying, am I hitting 99% of my success codes from my application are successful? I'm pulling that information from Prometheus.
Okay.
Prometheus is providing the metric. Argo Rollouts is analyzing it in an analysis run. The analysis run, which is running in line on that step in my canary deployment,
Mm-hmm.
has returned successful. Now it's going to progress to the next step, which is 25% of my traffic. And then I
Okay.
rerun my maybe a different analysis, maybe the same one, let's say the same one. But on
Uh-huh.
this new step, I'm exposing 25% of my traffic to the new version, and I'm sending only the Mozilla Firefox Mac OS traffic to that new version. And I run
Uh-huh.
my analysis run, and it turns out now, uh, you know, uh, 5% of my traffic is failing to load the page for some reason. I'm getting a bunch of 400 responses from. I'm serving up a
Oh.
bunch of 400 responses to my
Mm-hmm.
users, and that actually causes my analysis run, which is looking for 99% successful, to fail because it's
Uh-huh.
now 5%, and it did that 3 times, and it hit the failure limit. So it's actually going to fail my rollout,
Mm-hmm.
and this is going to trigger Argo rollouts to, we were 25% in. It's actually going to scale down the old replica set.
Okay.
And depending on how you configure, either scale up the old replica set or it stayed scale up and now just reference the old one. And it's removed the new version from the cluster and has
Uh-huh.
entered I think it's degraded state. That's a nuance,
Oh,
but the
rude.
rollout has now said, like, I was unsuccessful, and that's a
Uh-huh.
status that you can monitor for in your cluster on that
Uh-huh.
resource. And now it's up to you to go and respond and be like, why did we fail, and how can I prevent that failure? You can go look in your observability tools to determine why.
Okay. That was amazing. You really brought me on a journey. I was with you.
Thank you.
This is there anything you'd like to say before I do the recap? Is there any new information you'd like to impart?
Yeah. Like, I think this is a fantastic overview of what Argo rollouts can do. I think
Mm-hmm.
it's fair to mention what Argo rollouts can't do, which
Mm-hmm.
it doesn't make a change in Git when the rollout failed. It's not going to go and roll back the change in Git for you. It's going
Okay.
to enter a degraded state within the cluster, and now
Uh-huh.
you have a mismatch between desired state and live
Oh.
state in your
Uh-huh.
cluster. And so it's important to be aware of that when you're operating Argo rollouts, is that you need to act on failed rollouts, and ideally not leave it in that state for too long. Otherwise, you're going to get this disconnect between your shared understanding desired state in Git and what's actually running in the cluster. I have version 2
Yeah.
in Git, but I'm not serving v2 traffic. What's going on with failed
Okay.
rollouts?
Okay. And I suppose that issue happens with anything that's failed that you try to deploy with GitOps
Certainly.
and fails. Yeah.
Yeah.
But important to mention too, especially since they're both under the same Argo umbrella, then you might
Mhm.
assume tighter integration than you would assume if it was like I don't know, like a Kyverno whatever that
Yeah.
failed. Yeah.
Yeah. So it has no connection to the GitOps side of it, despite it being very important. It's not going to, and the other challenge is that it only can do a progressive rollout to one instance of your application. So you can't do a progressive rollout from dev to QA to production unless you're doing traffic management stuff, which, okay, maybe, but it's not the best way to do it. You can't make a change in dev, deploy it to dev, progressively roll out, and then if that's successful, now make your change to QA, and now make your change to production. You end up relying, people either end up writing their own scripts, or there are open source projects like Cargo that take the GitOps side of it into consideration. But Argo Rollouts is only
Ah,
ever going to know about that one deploy target.
okay. And that maybe is where like these resources can be repeated to make
Mhm.
the other I mean, they wouldn't exactly be a chain because there's no trigger to trigger the second one. But
Exactly. It can't
yeah.
say, I was successful in dev, now make my change in Git to deploy that change to QA and then have the rollout. Um,
Okay. So that's
yeah.
like an open source project called Cargo. Is it
Yeah.
Argo Cargo?
Cargo Argo? No, Cargo,
Okay.
Argo with a K. And yeah, it starts
Okay. Got it.
taking Git into consideration and does the continuous deployment, like creates a whole pipeline that can go along all of your environments rather than focusing on a single deploy target in one environment.
Okay. Cool. That's awesome. Okay. Well, before I do, let's talk about what if people want to learn more? Where should they go next?
I am honestly pretty impressed with the documentation for Argo rollouts, and that's not self-serving. I haven't contributed much to them, but it's surprisingly in depth with the number of examples and the clarity it provides on how it works, both at a technical and conceptual level. It's honestly, the docs are a great introduction to progressive delivery in the first place. But after you kind of started looking at the docs and you want to go try it, definitely check out the examples in the Argo rollouts um, repository, because there are a ton of analysis template examples and rollout examples that you can go and actually play with on your own. Argo rollouts is like 2 commands to get it installed into your cluster, a little bit of extra configuration to connect it up with your metrics providers if that's what you want. But you could test out simple blue, green, or canary steps without having to go through that additional configuration. Take a guest book, deploy it with a deployment, transition it over to a rollout, and then try changing the container version and play with the strategies.
Fun. So the docs probably have a getting started for super duper getting started, and then when you're ready to go further, you can go to that
Yeah.
GitHub.
Yeah.
And
There's
then
a basic getting started. Yeah.
and then a quick shout out for you for being an awesome guest. Everyone follow Nick. That's the I don't like how big my name is compared to yours, but follow Nick. And I think that's all for that part. We can always add some more if anyone has questions about getting in touch with either of us or what to do with questions. But I think we have a good start there. Let me get the names off. Okay. Now let's test Whitney's knowledge. Let's see how we did. So all right. So before Argo rollouts, or even now actually, the native deployment process in Kubernetes is lacking. And we talked about specifically how that process works. So what happens when you make a deployment in Kubernetes without Argo rollouts is that it will create a deployment, and that deployment will create a replica set, and that replica set will make one or many pods. And then
Mhm.
when you make a change, you have the same deployments, but it makes a new replica set, and that replica set makes new pods. We drew a picture. And so there are two, and natively in Kubernetes, there are two update strategies. You can either recreate where all of version 1 goes down and then all of version 2 comes up and you have your application is inaccessible for a while, which who wants that? And then the other one is rolling update, which is the default, which means that one v2 pod will come up and then one v1 pod will go down and then the next v2 pod will go up, and you can configure it to be more than one and one, but that's about it. Rinse and repeat until it's done. And then this will matter later, but in Kubernetes we also have some inferior traffic splitting options between services.
Mhm.
Those are done with selectors, and it's really coarse grained, like whole numbers only, or you have to point at those selectors. Yeah. So, but the shortcomings of this Kubernetes rollout process, you have no control over the speed of the deployment, how fast it's rolled out. You can't split traffic between version 1 and version 2. There's no way to verify that version 2 deployed correctly before you keep rolling out version 1. And so therefore there are no automated rollbacks. So then we talked about, I thought we were going to get into Argo rollouts, but first we talked about progressive delivery generally. So progressive delivery is the process of releasing software and software updates in a slow and gradual manner, therefore reducing the risk. And it's with current events as they are, it's a perfect time to think about this. So there are 2 big progressive delivery strategies. We have blue-green deployments, where blue usually refers to your blue deployment's your older app, and the green is the new app. And so you run both versions alongside one another, and then once you're good, feel great, you could test that green version, and you feel good that it's ready, then bam, send all the traffic to green. Just do it. But then you keep blue running for a while so that if something goes wrong with green, you can get it back to blue real quick. Or you could do a canary deployment, which means you actually expose a subset of your users to the new version. So it usually starts out a really small percent, 1%, 5%, go to the new version. So if the new version, something is wrong with it, only a little bit of people are affected, only the unlucky ones.
Only New Zealand or
yeah. And then you gradually, so with a canary deployment, you give that little bit of traffic to the new app of real traffic. And then once that's good, and you verify that's good, then you give a little more. And then you verify that's good, and then a little more. And then eventually you observe, you analyze, you test all along the way until eventually all your traffic's rolled out to the new version of your application. Those are the 2 different ways. And then, so therefore, all that awesome background information we have, what Argo Rollouts is Argo Rollouts is a controller and a set of custom resource definitions that add progressive delivery functionality into Kubernetes. So we talked about 2 resources, kind of 3 if you count analysis run as a resource, as a way to do this. So in Argo Rollouts, we no longer, anything that used to be a Kubernetes deployment is now called a rollout instead. It's a rollout. And so we kiss goodbye to Kubernetes deployment objects, but there are like drop-in replacement, like a rollout is a drop-in replacement for a Kubernetes deployment object, and you do have tried and true methods to migrate from one to the other. So the rollout replaces that native Kubernetes deployment object, and then the rollout object has this functionality that includes progressive delivery strategies. So it has a blue-green strategy and canary strategies built in. So if you use your rollout to make a blue-green strategy, you can create and manipulate Kubernetes services. So not just pods and replica sets like here, but you could also manipulate services. So there could be an active service and a preview service talking about where we're sending traffic. And then with canary deployment strategy, for that you define a list of steps of how you want to deliver change. And the example you gave is like 5%, then 25%, then 50%, and like that. So each step in a canary deployment, that's part of the rollout, each step has 2 fields, what percent of traffic, and then how long to wait before the next step. There's a pause. So the thing that the analysis template is what we're about to get to. So the thing in both of these is like knowing when to move forward to the next step, or also knowing if something's failing to hurry up and stop. Like you would know that, knowing that as soon as possible, and automatically rolling back as opposed to needing to wait for a human. So the analysis template is how that is decoupled from the rollout itself. So analysis template, with that you can pull information from observability providers, or you could use Kubernetes jobs or HTTP requests, but you need to get metrics for how well something's working. So you have a way to receive metrics. You also, as part of your template, you specify a success condition, and then a failure limit. You specify your metrics and your poll interval. But I think the important thing is that success condition. Like what does you're defining success, and then an analysis run is an instance of an analysis template. So this template is like how it works and it can be used, but then what's going to actually happen in your rollout is an analysis run. So analysis run uses this analysis templates, and then it has 3 possible results. You could have a success or a fail or inconclusive. So therefore, when you have this blue-green or this canary is an easy one to give an example because there's a step. So you have one step, and then as that step, part of that step is an analysis run. And then you could say, once my condition for success is defined, is succeeded, then we're going to move on to the next step in the canary deployment. And the way to find that success is with the analysis template, or like define what the success is with an analysis template. So if you have success, if an analysis run that's in a part of your rollout, if it's successful, you move forward. If it fails, you roll back. If it's inconclusive, you press pause and you may wait for a manual intervention. And that's the nutshell of how it works. Is that good so far?
Yeah, I would say that's all correct.
Awesome. And then I'll say one more thing that we didn't get to write down is this analysis run can happen as part of the steps, like in the moment, or it can also run in the background. So you could have it as like, okay, as part of this step, we're waiting, and then once analysis says run happens, then we move forward, and it's concrete like that. And it always speaks when spoken to, when asked its opinion. Or if you're having it run in the background, you could have just something always saying like, if this failure happens, stop everything. I don't care where you are in the process, alert, alert, alert. So there are 2 ways it can be used. And then we finally talked about traffic management. So Argo Rollouts can integrate with service meshes. And so with that, it can do advanced traffic management, like, for example, header-based routing, where you use headers, which in your example is a good way to know like what browsers your users might be using, so you could test for certain browsers. Or you could also do traffic mirroring. And I imagine other advanced traffic managements, but those are 2 examples.
Yeah.
And then one more thing that came up a couple of times that I didn't write down but will say is Argo CD, the GitOps project, is different from Argo Rollouts. And they, of course, can be used together, but they don't have to be used together. Yeah. Is there anything else you'd like to add? Did I miss anything?
No, I think that was a fantastic recap. Anything you've missed, I missed.
Well, this is a testament to your really wonderful teaching, because I really knew nothing about Argo Rollouts going into this. So this is you did a great job of teaching together and with the community's questions too. I feel really proud of what we've made today. Me too.
I like it. It's weird to see it all written out like this, and I think it covers everything, but I'm sure not the nuances, of course, but conceptually somebody could look at this and by the end of finding all the pieces, maybe be motivated enough to try Argo Rollouts.
Oh, I hope they do. It sounds fun. And we have a couple of like wonderful comments too that I want to say. We have just said thanks. What I love about these comments is all y'all said hello too. So you've been with us these whole 2 hours, and I appreciate that.
Has it really been 2 hours?
1 hour and 50 minutes, but who's counting? Kormaju, I miss you. Thanks for your great questions. I'm glad you're here. Thank you. Okay, with that, I'll say, actually, let's highlight one more time the docs. If you want, there's getting started there is a great first place to go. And now we're going to dance our goodbyes like we do. So thanks everyone for coming. Thanks everyone who watches the stream later. Thank you, Nicholas. We've been friends we've been seeing each other around at conferences for a while, and it's our first collaboration. And it was everything I hoped and dreamed it would be, Nicholas.
Me too.
Thank you. Thanks everyone. Goodbye.